everyone, I am Rishabh Anand from Chandigarh University. I'll be your host for today. And as the title suggests, this is a session on Introduction to Python, and this is powered by LetsGrowMore. So first of all, I'd like to thank GrowMore for giving me this opportunity to come in front of all of you and give this session and share my knowledge about Python. So without further ado, let's dive into it. So first off, why Python? It's because it's awesome and it's easy. So I say it's awesome because it's a very high-level language that is very close to English. So Python basically reads and functions exactly like how we talk and how we write in English. For example, we use fors and ifs in English, but I'll get to that in a second. And it's easy because the syntax is very easy in Python as compared to C and Java. Python is also very versatile. That means it can be used in a number of things, and it is being used in a number of things. For example, people are using Python in automation and all the way to machine learning. So people use Python to automate their daily lives, daily tasks, and some people use it for more complex stuff like predicting and making models and getting predictions out of it. And as Bruce would say, life's better without braces. So we don't have braces in Python. We use indentation to make blocks of codes run under certain statements. So let's see how that happens. So first off, what is a programming and what is scripting language? So as I would say, Python is a scripting language, not a programming language, essentially. So a program needs to be compiled and then it runs, right? That happens in programming languages like Java and C++. But in Python, since it is an interpreted language, it doesn't need to be compiled. It only goes, you can edit and you can run the file at the same time very quickly, and it increases your speed and efficiency. So today we'll be talking about interactive shell, the basic types like numbers and strings, containers like lists, dictionaries, tuples, and variables, and then we'll be moving to control structures like if, while, and for, and we'll also see statements like break and continue. Then we'll be moving towards try and except block, and then finally we'll be ending the session with file IO. So what is interactive shell? So interactive and then you can just hop onto your CMD and you can go Python, and there we go. You have a Python interactive session with you. And now you can do all sorts of stuff with Python. So for example, you can go like print hello world, and that would print hello world, just like that. So that's how easy it is to code in Python. Numbers, and you can also have comments in the interactive shell to help us specify some things or help us remind of some things that are there in the shell. So that's how it works basically. And then moving on to numbers.
Yeah, Rishabh, you carry on, no issue.
Yeah, actually I have an unstable connection, so I'm so sorry for that. So actually, so we were talking about numbers, right? So we can have numbers and strings in Python shell. So if I move back to my shell, I can see that I can create a variable and I can assign it to a number like 10. So now in C++ or in Java, I'd have to first initialize a variable and assign its data type, right? Like I'll have to go int I equals 0 or something like that. So, but in Python, I don't need to do that. I can just start and I can assign directly a value to the variable, and I can see the variable like this. You can see it's 10 right now. But what if I want the variable to hold a string value or a character value? I don't need to reassign a variable or recreate a variable. I can just enter the value in this variable only, like here. Now it's containing a string character that is a. So this is why I said Python is versatile. You see, the same variable was containing an integer value. Now it's containing a string value. So you don't need to recreate a variable or reassign a variable a type. You can just change the data and the value gets changed. Now moving towards this, we can have functions. So if you need on the go calculator, you don't need to have you don't need to create variables, and you don't need to have a whole program for that. You can just type this and you can get the answers. Not only the easy answers, but the difficult one is that, like let's see, 200 to the power of 100. You can have that too. So that's easy. That's how easy Python is. And that's how you can also have multiple statements like this, and it all works out. So now there are actually two types of division in Python. One is integer division and one is float. Yeah, so I was saying there are two types of division in Python. Like 3 divides 2 gives 1.5. This is the float division, and if I want the integer value or the floor value of this division, I can do double divide, and that will give me 1. So that this type of division truncates the decimal part of the output and gives me the integer number only. Now we also have a modulo operator that gives me the modulus of two particular numbers, that is the remainder left after dividing the numbers. And we also have the power function, which gives me the uh, power of the specific number, like that. And we also have support for complex numbers inbuilt into Python. Like what if I wanted to work with vectors, right? So I can have a vector like this, and this will give me a vector value that is 3 plus 4j. Now what if I wanted the exact or absolute value of this vector? So there's a function in Python for that, that is called abs, or absolute function. So if I pass absolute function and if I pass x into it, I'll get 5. That is the length of the vector, or its absolute value. So that's regarding numbers in Python. Now moving towards strings, we can see there are a number of operations that we can perform on strings. I hope you can see that. Yeah, so we can concatenate strings, we can repeat strings, we can index strings, we can slice it, we can size, and we can search for certain particular values in a string. So let me show that to you real quick. For example, let's say I have a string called hello, and now I wanted to say hello, so I can just print x. Now what if I wanted to say hello 3 times for some reason? So I can do something like this, and it will print hello, hello, hello 3 times. So now there's a way to print hello, hello, hello 3 times. I can just print hello, hello, hello like this, but that is ugly, and we should not do it like this, right? Because we can print it as many times as we like using the repetition function. So that's handy and that's easy. Also, we can add 2 strings together for, like, let's say I wanted to print hello Rishabh, right? So I can just print it like this, and it still works out because it's Python. So that's there we go, hello Rishabh. And what if I wanted to search if E is present in the string? So how do I speak that in English? is E present in the string? So that's how we type it, or that's how we query it in Python. Is E in string? And it's there, so it says true. But if I wanted to search F, so is F in string? And no, it's not. So it says false. And what if I wanted to get the hell out of hello? So I can do something like 0 to 4, and it will give me hell. That was a joke. Okay, now we can also we can also get in individual letters like this. And Python also supports reverse indexing. So if you don't want to calculate the number of indexes from the beginning, you can also calculate it from the very last. So if I wanted to get O, I could get that in two ways. I can print this, or I can print this. It both gives me O, because Python supports negative indexing. Now, what if I wanted to reverse a string? In C, I'd have to iterate through the string and then print it on the reverse order. But in Python, we can just do this, and it works out. So this is how strings work in Python. Now, let's say I wanted to get the length of the string. So I can write a function for that, or I can use the built-in function, that is len, and I can get the length of the string, that is 5. Now notice that the indexing works from 0 all the way to 4, but the length function still counts from 1, that is 1, 2, 3, 4, and 5. So that's how strings work in Python. Now I can also talk about lists. So I like to think strings as lists of characters. But when we talk about lists, a list can consist of anything. It can contain integers, floats, booleans, strings, or even other lists. So an example for that would be, let's say I wanted to create a list 1, 2, 3, 4, 5.6, and let's say 7. So you see, there's a list. Now in C or Java, this would be a drastic error, because we cannot create a list with multiple types in it. If we have a list of strings, we need to have all the string values in it. If we want to have a list of numbers, we need to put only numbers in that. But in Python, we can use any type of value in a list. So I think that's really handy and very good. Now, what if I wanted to add more values to this list? I can use the append function to add values, and it will I'm sorry, I spelled it wrong here. So I can use the append function to add values to the list, and it adds the value to the very last. Now, what if I wanted to remove a value? So I can use the pop function, and it removes the last value. And you can see the last value is removed, and the string is back to what we started with. Now, there are other ways of adding to a list and removing from a list, but I don't think I'll be getting into it because I have other topics to cover. Now I can also slice, and I can also get particular items from a list. For example, if I wanted to get 7 out of the list, I can do x minus 1. It will give me 7. If I wanted to get a particular slice of numbers, I can get that. And if I wanted to print numbers in reverse order, I can still do that, because as I said, string is just a list of characters, right? So I can still do that. It still works out. So now if we move on to the next slide, we see that there are more list operations that I just talked about. The insert function is basically about adding the number or the value at a particular index. And the pop function, I talked about it. And there's a sort function for lists. So let's say I had the list of numbers for 4, 5, 6, 1, 2, and 3, and I wanted to sort it. So I could use multiple sorting algorithms like bubble sort, or binary sort and stuff like that. But I can, if I'm in a hurry, I can just I can use this, and it still works out, because there's a built-in function for lists, for sorting lists in Python, that is .sort, and it sorts the list for me. And what if I wanted to reverse the list? So there's also a function for that. I can always use the indexing part, but if I ever forget that, or if I'm not able to do that, I can use the x.reverse function, and it will still work. So if you wanted to get the descending order of numbers, you can use sort, and then you can reverse, or you can reverse and then you can sort. So it still works out. And now moving to on to dictionaries. So again, in my opinion, dictionaries are customized index lists where we can have lists with custom indexes. So the way we there are multiple ways we can define a list, and we can add values to it, we can remove values from it. So I'll not get into the slide, I'll show you myself. So let's say I have a dictionary where I have keys like key 1, and it has value of 10. Then so this is how we create a dictionary. We use curly braces to create dictionaries, and we use square brackets to create lists. So that's something very easy and to remember. So now if I wanted to see the list, I can use this. Now, the first part, that is this part of the dictionary, is called key. That is the customized index, I'd say. And then there's the 10 part, that is the value at that specific key. So if I print if I print D0, I'll get an error because there is no key named 0 in the dictionary. I customized the index, and now it's called key 1. So if I put key 1 here, sure enough I get 10 because that's how I customized it. Now what if I wanted to add another key and another value to the dictionary? So I can just put this, and I can add key 2, and I can put 20. Now when I see the dictionary, I have another value, that is key 2 and 20. Now notice that I don't really need to append it. Like I don't need to name it key 2 or key 3 particularly. I can just name it anything. For example, let's name it Anand, and let's have a value Rishabh in there. So you see, you can customize lists in Python, and they are called dictionaries. That's how I like to believe, and that's how I learned. Now what if I wanted to see all, now what if I had a long list or a long dictionary, right? And I wanted to see what keys are in there, because sure enough at some point I'll forget what customization did I do to the indexes, right? So I can use d dot keys to get all the keys, to get all the keys from the dictionary. And I can do d dot values to get all the values from the dictionary. Okay, so that's one way of seeing all the keys at one place and all the values at one place. And again, what if I wanted now that I'm seeing that Anand and Rishabh are not really fitting into the dictionary, right? They are not key 1 or key 2, or it should have been key 3. So I can remove that. So I can do del and then d and a and a and d, and it deletes the value from the dictionary. Now I can talk about items that. So d dot items basically converts into tuples, and d dot has keys is used to check if a dictionary has a particular key. Like I removed Anand from here, right? So now I can, if I check, it should give me an error, right? So that's how dictionaries work. And I can also have another types, like I can have a dictionary of lists, I can have a dictionary of multiple things. Now moving on to tuples. So tuples are basically smaller lists that are immutable. That is, I cannot change a tuple once it's created. So if I create a tuple key equals 1 2 3, I cannot change it again. Now there are multiple ways to creating tuples, like using the packing operation, or using the parentheses operations, or using the trailing comma to create singleton keys, or even using empty empty keys to actually print, to actually create empty. Let me just clear the screen first. It's too cluttered for now. Okay, now I can create a key for, let's say, coordinates, and they are, I don't know, 1 2 3. So now I can still access coordinates like that. I can still get those, but I cannot change that values. Like what if I wanted it to be 4? So fair enough, I cannot change the values because I just said that tuples are immutable. That's once they are created, I cannot change them. Now working on to variables. uh, I said this before, unlike C and Java, we don't need to declare variables to work on them. We can just have a variable and we can assign a value to it on the go. And variables are not type. That is, they can have string values, or they can have integer values, or they can have boolean values, or any kind of values. You don't have to specify the data type of the variable. Now moving on to control structures. So one thing to note about variables that was not in the slide, that is, you cannot start a variable name with a number. So if I have a variable x equals 10, so that works out. But if I have a variable name 1x equals 10, that will give me an error, because I cannot have a number at the beginning of a variable name. I can have a number afterwards. I can have as many as number as I want afterwards, and but I cannot have them before. So that's regarding nomenclature of the Python series. And now moving on to control structures. So how do we make decisions in life? We go like, okay, if this happens, I'll do this. If this happens, I'll do this. So it's the same in Python, right? You can just have if. Let's create a variable first. If x, I say x is equals to 1, right? And then I check if x is equals to 1, I'll print x. Else I'll print, I don't know, Rishabh. Okay, and now you see 1 is printed, because Python was like, okay, I have to check if x is equals to 1, and then if it is true, then I have to do this. So notice the indentation part here. This is what I was talking about. We don't have multiple braces in Python. We just we just indent things to a certain degree, and then whatever it is inside of this particular indent comes in the if block and is executed if the if block is true. And similar, it's with the else block, and we use semicolons to start a particular block of code. For example, I can have multiple lines. Let's say if x equals 1, I'll print x, and then I'll increment x with 1, or else I'll just print Anand. So you see it prints 1, and now if I check the value of x, it's 2. That's because this block, this particular line here, also got executed because x was equals to 1. Now if I run the same program again, or the same block of code again, that is, if x equals to 1, I'll print x, and else I'll print no, for example. So now it should print no, because you see x was 2 here, and I was checking if x is 1. So that is false. So this particular block of code got executed, and no was printed. X equals 1. I'll print, I don't know, x plus 1, and else I'll just print, I'm sorry, I'll print okay. So here we have two conditions to check, and let's see if that works. So as you can see, x is printed because x was 2 here, so this block didn't get executed, but x was equal to 2, so this block got executed, and the value that of x plus 1 was printed, that is 3. And now if I check it, the same program, it should print okay, but I will not get into that because I hope you all get it. Now moving on to the while block. So there's another control structure, that is while. So while is basically used to iterate or do a certain thing until a condition is true. So moving on, let's just demonstrate while real quick. If I have x less than equal to 5, then I'll keep printing x, and I'll increment the value of x to 1. Now there we go. So x was 2, and then it got printed. That's why it got printed. Then 3, 4, 5, and then when it was finally 5, it exited, right? So that's how while works. What if I didn't put x plus 1, x equals x plus equals 1 at the end? Let's see what that happens. So x greater than equal to 10, and I print x. So there we go. It keeps printing the same number because this is what we call an infinite loop. Because I'm never incrementing the value of x, so it's always 6, and it always satisfies the condition, and it keeps printing the same thing. And it's very common to run into infinite loops once you're programming because, well, it happens to newbies. And if I wanted to get out of it, you can press Control C and you'll get out of it on the shell, or you can just stop the program, kill the interpreter, and you're good to go. So so one thing that can prevent this is the break statement. That is, I can have uh, I can have the break statement like. Wait, let me clear it out. Now, so I was talking about the break statement, right? So there we go. First of all, let's assign a value to x, that is 1, and no, let's assign 10. Let's do that 10 times, right? Yeah. Now, while x is less than or equal to 10, if x mod 2 equals 0, I'll print x. Else I'll print I don't know. Else I'll just continue. So this again ran into a the infinite loop because I didn't increment the value of x. So that's how it goes. So one way to break it is using the break statement that works like this, and then having else and then continue. So you see, it printed it one time because it came here, and then it broke the loop. So what break does is it breaks the innermost loop, and it gives back the control to the main program. That is, the loop was this, and when I ran the break command, it broke out of this loop and it ended the program. So that's how it works. Now let's see another example of continue statement, right? So what if I had the same program, and if I ran this code, if it's equal to 2, the same program, and I'm still printing the number. I'm still printing the number like I don't know. Okay, I'm still printing the number. Let's print the number if it's okay. While x is not equal, x is greater than equal. If x mod 2 is not equal to 0, then I'll print the number. Print the number. Else I'll decrease the number by 1, and then I'll continue. So let's see now what happens. It prints 9. It keeps on printing 9 because once I ran the program, it went to the else part, and then the value became 9, and then it never got checked, right? So what can we do now? We can have something like if x mod 2 is not equal to 0, then we decrease the value by 1, and if it goes, we can print the number. So it's printing 8 now. So I hope you get what point I'm trying to make. Now moving towards grouping indentation. But first, let's talk about the for loops in Python. So for let's say I have a list of numbers. That is, list of numbers is 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, and 10. So this is the list of numbers. And what if I wanted to print every number in the list? So I can go like for I in list li, I want to print the number. So you can see every number got printed. So how that worked was, how can I speak that particular thing to do in English? So I'll say, okay, I have a list li. So for every value in li, print the value. For value in list, print the value. That's how high level languages work, right? That's how close Python is to English. Okay, now moving on towards, but this is kind of inconvenient, right? Having a list of numbers, specifying a list of numbers, then seeing if value is in it. So there's a function for that, that is called the range function. So that function is actually very handy, and it gives me a range of numbers in list form. So let's first uh, range. Let's see what range function does. So it gives me an iterable value, and then I can iterate through that value. Okay, so if I wanted to, for I in range 1 to 10, I want to print I. And you see, the range function excludes the value that is here, so it always runs from one less than the value it's given at the second point. Okay, so if I wanted to print the first 10 numbers, I'll have to pass 11 there. So I can go like this, and then I can print I, and there we go. We have the first 10 numbers. Now what if I wanted to let's make a small program to print all the even numbers and then print all the odd numbers. Okay, so how we can do that in Python? How do we say that in English? So let's say for every number in the range 1 to 11, check if the number is divisible by 2. If it is, then print the number, uh, else just don't print the number, continue. Okay, so there we go. We have all the even numbers from the range 1 to 10. Now notice that the continue block does essentially nothing and passes on to the next iteration of the loop. And what if we wanted the odd numbers here? So we can make the same program in range 1 to 11, and then we can see if I mod 2 is not equal to 0, and then we can print the value of I, else we can just continue. We don't have to do anything. So there we go. We get all the odd values from the particular range. Now you see, this was done in 1, 2, 3, 4, and 5 lines, right? But the quality of a good code is that it's always shorter. Okay, so the shorter the code, the better it is. So I'm going to shorten this code, but how? So let me introduce you to the final argument of the range function, that is the iteration part. So what it does is it iterates, it gives you the value by how much to iterate. So by default the value is 1, and if I pass a specific value, right, then it will iterate with that value. There we go. So as I passed 2 here, so it went over to every second number in the range. So that's what I meant by iteration value. We had that in C as well, where we used to initialize I equals 0, then I less than particular number, and then I plus plus. So I plus plus used to be an increment operator, and here we have the same operation, but in a shorter and more efficient way. So that's regarding the for loops. Now we can move on to grouping indentation. So as Bruce said, world is better without braces. So in C we'd have braces everywhere, right? We'd have braces for, we'd have braces for ifs and elses and whiles, but we don't need to have braces in Python. We can just indent it to a certain degree, and that particular indent serves as a block that used to be defined under a particular brace. So you can see here this particular thing is inside this indent, right? So everything under this indent is one block of code. Similarly, this particular thing is inside this indent. So this thing is a one block of code, and similarly, this particular thing is inside another indent. So this is another block of code. I hope I'm being clear here, and you get the indentation part. So naturally, indentation is really important in Python. and you need to specify and check if you have the perfect indexes, indents working with you. Now we can move on to functions. So let's moving on to functions. Let me go back to my terminal. Actually, I'd like to do the functions part on any IDE, because it's easier there. Let me just print a small function here. Let's have a function called add, which takes two values, a and b, and then it returns me the sum of those values. Now, you'd think that this is only applicable to floats or integers, right? But Python is different. This same function can work for strings and lists as well. For example, let's see what 2 comma 3 prints. 5. That's natural, right? Let's see what 3 plus 4.5. I'm sorry, 3 comma 4.5 feels like. So it's 7. But what if I pass in string value? So let's see. A string value is a, another string value is b, right? And in C or in Java, this would lead to a drastic error again. But since it is Python and it is versatile, I get AB. So this is how string concatenation works, remember? So I'm still adding the values and returning them. And what if I pass to so similarly, it can work for list as well. Now, one way to exit the terminal is literally just type exit and boom, you're out. So now let me move back to my IDE. So here I had the same function there. And let's see if I have a function for, I don't know, print greeting. Let's say I had a greeting function which took name, and it then return me the value of hello plus name, right? So this we can work like this. Let's see how it works. Now, if I run this program, you see that nothing happens because I haven't called the function yet. So to actually get the values out of function, I need to call the function. Okay. So let's say I want to greet Aman here. So I can pass this. I'm sorry, I misspelled it, and I misspelled it here as well. Now, when I run this program, nothing happened because it's still returning me the value. But since it is not the interactive shell, right? I actually need to print those values. So how we can do that is we can use the print statement to actually see what's happening here, what I'm getting in return. So let's print this, and you can see hello Aman is printed here. I hope you can see that. Let me increase the size a bit. Yeah, so I hope you can see that. Hello Aman is returned here. And what about but this is every time I run this, I'll get the same value, right? Aman, 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 Aman. But what if I wanted it to be, different values as well? What if I wanted someone to have a different value? So I can pass another value here, A and D. But this is still tedious, right? Every time I give this program to a new person, I need to tell him to edit the program and to enter his name there. So what I can do is I can actually use input function here, which is used to take input from the user. So now when I run this code, this will not print anything until I enter my name. And there we go, hello Rishabh, right? So this is what the input function is. It helps you to take input from the user, okay? Now, a new user won't know this because when I run this, nothing happens, right? The program is still, the shell is frozen, the person might think the code is broken, right? So I actually need to tell him to enter something. So I can actually pass my message here, that is enter your name, and then we can actually work. So if I do it like this, you see now it's asking me for my name, and when I enter my name here, hello Rishabh, there we go. And we get, so by default the value of the input statement. So let's talk about the input statement more, right? So let's see, x equals input, and then when I print x, what happens? Input anything, enter. So when I enter 1, it's printing 1, but I wanted the 1 as a number, right? So let's try adding it, or let's try multiplying it and see what happens. So if I enter 2 here, I am expecting the value 6 to be printed, right? Because I want the number 6. I want 2 into 3. But look at what happens here. I'm getting 2, 2, 2. So that is because input function always returns a value that is a string value. So if you remember, we had something where we were working with strings and we were repeating strings using the multiplication operator, and this is how it was working. If you remember that, here. So that's what's happening essentially here. Now, how can we overcome this? What if I wanted to use it as a number, right? So actually, I need the type of the number. That is this. Okay. Now when I print x into 3, so now when I run this and I enter 2 here, I get 6, sure enough. That is because I changed, or I typecasted the value of the function of the input to another to the integer type, right? We can actually check what type of it's taking a while to load. I don't know why.
You can carry on.
Okay, so I'm so sorry for that. I guess the internet here is very bad. So as I was saying, the you cannot understand the values if you just print the values, right? You need to actually see what the type of the value is. So if I print x here, I'm still getting 2, but the type of 2 is string. So now when I typecast it into integer, and then when I print the value of x, I'm still getting a 2, but notice that the type of the string is now integer, and now I can perform any type of integer operation on the number. Like I can do this, or I can do this, or I don't know, I can do this. So when I enter the number, you can see I still get x plus 2, x minus 2, and x to the power x, that is 3 to the power 3, that is 27. So that is how input function works in a list. in Python programs. I'm sorry. And moving on to the function here. This is an example function of GCD where we are calculating the greatest common divisor of two numbers, and here we are actually, you know, this is a great example of docs right here. If you can see, yeah, here. So this is how you can actually add documentation to your code. We'll get to that in a second. And first, let us talk about catching exceptions, right? So throughout the session, you have seen me getting multiple kind of errors, right? Some of them were on purpose, some of them were honest mistakes that I made. So it can happen to any of us, right? So there's a method, or there's a procedure that you can follow to actually counter those errors, or escape from them. So you can use the try and except blocks of Python that actually supports, or that actually helps you when you have an error. Okay. So what it basically does is, let me just remove all this, and let's see if the number is 10, and then I have I'm trying to divide the number by 0. So if I run this, you see this is an error, right? Zero division error, and this is a big message, and it looks ugly, and it makes me feel like I am a total loser, and I am a beginner, and I cannot code anytime. So you can conquer that, and that is very easy. But if you just do this, if you put this in a try block, that means try this particular set of code, and if it doesn't work, that is, if you get an exception, if exception, you just print I am sorry, or something like that. Sorry, I misspelled it. Yeah, there we go. So now when I try to run this, you see I'm getting I am sorry, because I'm still trying to divide that number by 0, and it doesn't work. So let's say if I wanted to divide it by another number, and I get that number from the user. So I just showed you how to get a number from a user, enter the number, and then I can get the particular exception. So now when I enter 3, so you can see I get 3.333, right? Because 10 divided by 3 is 3.34. And when I again run the function and I enter 0 here, so you see I'm getting a I am sorry, right? So that's how try and else block work. Now another type of exception can come when if I enter a here. So a is a string value, and when I try to convert it to an integer, I should get an error, right? Value error. I cannot take a value of base 10, right? So it is not working with strings, and it looks it makes my code prone to errors, right? So I can actually move the part here, and then what happens that if I enter a string now, it again prints I am sorry, because this is also catching this error and giving me the except block here. Okay. So you can have multiple exceptions, and like if you have I had a value error, right? So I can print I'm sorry, value error, and then I can actually see, I can actually guide the user to overcome this. Enter a number, not string, except let's say I had a 0 error, right? So a 0 division error, I can actually print, and I can actually tell the user to do certain things to overcome this error, this particular error. So here the error was division by 0. So I can tell him to enter any number except 0. And I can also have, now what if there is an error that is not one of them, right? So I need to have a general case exception. I need to actually print I am sorry. So let's see now how it works. I'm still dividing the number 10, so let's divide it by 2. It works fine. What if I added 2 like this? Some people do that. So enter a number, not a string. You can see gave me this block. Now what if I enter 0 again? Enter any number except 0. So you can have multiple exceptions that you face during the testing of your code, and you can actually add all those exceptions separately to guide the user to fix his inputs. So that's how try and except work. Now I actually have another block of code, another block of to this try and except, that is finally. So finally actually helps me to print to execute a particular block of code, no, like not depending upon whether there was an exception or not. Like for example, if I run this code with 2, so I'm getting 5 and then I'm getting 2. That is because I printed y. Even if I get an error, right? Even if I get an error, I'll still print the value of y. So that's how the finally block works. It does not matter what you entered or whether there was an exception or not. It will always execute the finally block. So that's regarding the try and accept part of the code. Now, if we move forward, uh, we can have the try. I talked about this try and finally, and then raising exceptions. We can actually raise certain exceptions, and we can. There's multiple things about exceptions regarding Python 2 and Python 3. They are separate. You can check it out on the documentation. I'll not get into it since we are running out of time. And finally, I want to talk about file operations, and let's see how that works. So I can actually, as I said before, you can automate your work using Python, right? So what if I wanted to create a file that actually held my name in it, or actually appended the value what if I entered to the file. So let's say I opened a file open name.txt. So the open function creates, or it opens the file. It opens the file that the name you suggest. Here the file will be created as name.txt, and then we can have the type by which you want to process the file. For example, I am writing the file here. I'm actually putting things into the file, so I'll write w, that is write mode. So now I have opened the file name.txt in writing mode. Now I can actually write hello here, and then I need to close the file. So if I run the program now, and you can see there's a file named name.txt that contains hello here. Okay, so that is how file operations work. Now quickly I'll also show you how to read from a file. So I actually open the file in read mode, and then I can file.read, and then I can hello. If you have any questions for me now, I'll be answering those.
So, Rishabh, I'm audible.
Yeah, yeah.
That's great. So we have some question in the comment section. First question is like, what is IO? I/O.
Okay, so IO means input output. Okay, so in Python, as I showed in the very last session of our session, where I was taking input from a user and then displaying it. So the input part of the procedure was the I part of the IO, and the displaying part was the O. That is, I'm displaying the output. So IO basically means input output.
Great. Hope the next question, like, is it possible to add list in dictionary or dictionary in list?
No, actually, you need to specify indexes to. I said that before, right? You need to have a customized index for dictionaries. So you cannot add lists to dictionaries. You need to actually specify the particular indexes or particular keys for that. And for that, you can use zip or map. There are multiple ways. You can use list comprehension, dictionary comprehension, filters. So that's for another session.
Okay, that's great. Next question, like, what are the return type available in Python?
Uh, they can be data for numbers. integers, floats, strings, booleans, that is true or false, and list, tuples, dictionaries, sets, complex numbers. There's a long list.
Uh, Please explain difference between procedural and object-oriented programming.
Okay, so what is procedural programming? That is, I go to line one, I execute that. I go to line two, execute that. And what is object oriented programming? I need to actually have a certain kind of class that has certain kind of functions. And then I create objects for that class, and the object can only access or only perform the functions that are in that class. So that is object oriented programming.
I could never understand what is an object.
Okay, so an object is like, let's say I have a class, right? We don't have time to. I'll just explain it. So an object is like a real world entity. Like a car is a class, and then I have a I if I have a car. So let's say I have a Omni. So Omni is an object of the class car. So everything that a car has, that is four wheels, an engine, a silencer, it runs on petrol or diesel. So everything a car has, my Omni will have too. My Omni has four wheels. My Omni has an engine. My Omni has a silencer, right? And my if a car has functions like run, brake, accelerate, or something like that, so my Omni can access only those functions. Like it can accelerate, it can brake, it can run. I mean, not run, but yeah, you get my point, right?
Yeah, that's right. One more question is that what is error handling?
What is error handling? Okay, as I said, I made multiple errors during the session. So if that happens during a production code, or that happens when you are actually in you are giving the code out for real world, and you are actually using that code somewhere. So if that happens, your program is stopped, and then you cannot do anything about that, and it looks ugly, frankly speaking. So error handling is basically handling those errors, so that even if you run into an error, you know how to counter that, so that the user can fix it, or you can just display out that, okay, you ran into this error, you need to do it like this, then the program will work fine.
Can you show a demo how to implement object?
How to create an object?
I think we have a session with object-oriented programming with Python soon. So I think
It's okay,
for
I can just create a I can just create one thing, that is init, and then I pass self here. I will not explain everything, but I can show you how it works. So self dot name equals Rishabh, and then I can have a function here, self def display, and then I can pass self into it. Then I can actually print self dot name. So here I'm not a car, I'm a person. So I can just name it to a person. And then when I create, let's say X is a person, right? So now X is an object. The class was person, and X is an object. So everything that the class person has, X has too. So now if I do X dot display, you can see that. So when I run this code, I'll actually see my name here. That is Rishabh. So that was because the class had a inbuilt name called Rishabh, and I was just displaying the name. So that's how it works. You can have multiple functions that a particular object can fetch or do, as I explained before. I hope I'm
one
clear.
more, yeah, that's great. One more question is there, like what is the difference between Python and Java?
See, Python is very versatile. You can use it everywhere. Java is for people who have to code in Java. Like if you're in a company and your boss says you have to code in Java, you have to code in Java. But if you want to code, you go to Python. That's how I see it.
Yeah, I think most of the question we have covered. But I want to ask some question more, like why you think like Python is more versatile than Java and other languages?
Uh, in my opinion, Python has a easier syntax than Java and C++ and things like that. So it is easier for people to get into coding and to code. So many times it happens that I have an idea, right? Even if I don't know coding, I have an idea, a superb idea that I want to share, that I want to make an app, or not an app, but I want to give it to the world, right? An idea, but I don't know how to execute a code, how to write a code, how to program and stuff. So if I go with Java, even to print a single hello world program, I need a multiple 15 or 16 lines. So people run from that, but in Python I can just do print hello world and I'm good to go. So I'm not saying it's good, but good, if this language is good or that language is good, it's on you. But Python, coding in Python is significantly easier than coding in Java or coding in C++.
That's great. So one more question is there. Is the structure of object you just similar to XML?
I'm sorry, I didn't get that.
Structure of object is similar to structure of XML.
Structure of I don't know. I'll have to look it up. I have not worked with XML files, so I don't know. I'll have to look it up.
Okay, okay. I think you just showed. Okay, no issue. I think we are good to go. And Shishab, you can conclude like in a short message overall session.
Okay, so as I said, if you have an idea, you can always code it in Python. It's very easy, and if the best way to learn Python is to see the documentation and to code. You don't need to learn. You don't need to get a degree. You don't need to see. Okay, I need to get this course. You don't need to do that. You can just go to their website. There's a documentation. It's superb. That's how I learned it. I started doing projects. Whatever came into my mind, I started coding it. So I approximately made 900 scripts last summer alone. So whatever came into my mind, I just coded it. So that's how I learned Python. That's how I learned every language that I know, and that's the best way to learn any language or anything, in my opinion. Just start doing it. See the documentation where you're stuck. Take help from Google, and you're good to go.
That's great, guys. You can also fill the participation certificate form if you want participation certificate from us. I think Rishabh, if you anyone want to conclude about us, let's go more for future session and all.
But I didn't get that. I'm sorry. What did you say?
Yeah, I'm saying like we are going to come up with more session with you. So tell
Yeah,
us that
definitely. I'm
thing.
looking forward to it.
That's great. So guys, thank you so much for joining. Okay, one more question. Do we need to know all the function to work in a company?
You don't need to know all the functions. You can just see what the company is asking, and you can prepare yourself with that. Like if a company is asking for data science profile, so you don't need to know pygame and kinter and OpenCV for that. You can just know pandas, scikit-learn, and things like specific to your domain. As I said, Python is very versatile, right? There are multiple packages, there are multiple functions for multiple packages, right? So you don't need to know all of them. You can just pick one domain that you're interested in, and then make yourself good at that. And then when you are done with one, you can move to another and another, and there's no boundary to learning.
That's great. That's it. I think we are good to go. And a very thank you to you, Rishabh, and the whole audience who are watching here and who watched earlier. Nearly 200 plus people watched this, and hope all the people watch later also and find useful.
And thank you,
And
Aman,
again,
for
a
giving
very
me
big,
this opportunity. uh,
yeah,
this was all
a
because of
very
you.
big
Thank you so much.
with you, yeah, and you also, not only me, and whole members who are doing hard in the background also.
Yeah, all of them too.
Yeah, thank you everyone. Have a joining. Have a great night. Have a great night, Rishabh.
Good night, Aman.